Hi kids, we're back. So here's what we're doing is we're finding rate of change. And essentially what we're going to be doing is we're finding out, we're going to taking two data points, each that have two numbers. You can think of like a set of ordered pairs, like 2 comma 5 and let's say 4 comma 13. And we can say how much does the y change when the x changes by how much. So if we say, what does this change by? The y changes by, well, 13 minus 5 is 8. And how much does the x change by? Well, 4 minus 2 is 2. So then we can say, okay, that means then that we've got a rate of change of 4 in the y for every 1 that the x changes. Okay, and we're going to see this in a minute. Okay, so I know you're seeing this for the first time, so just remember that it will make sense eventually if it doesn't quite make sense yet. But here's the information that we had up top. Remember the change in the dependent variable, and the dependent variable is the y value, or um, that second column in a lot of what we're going to have here, okay? Over how much does the x value, or that first column, change. And so we need to actually take 2 points and calculate it. And so they take, for this problem, they say a marching band shows the distance the band marches over time. What is the rate of change in distance with respect to the time? Is it constant? Meaning, do we get the same amount every time no matter which data points we use? What does the rate of change represent? Okay, so they say after 1 minute they've gone 260 feet, after 2 minutes they've gone 520 feet, after 3 minutes 780 feet, and after 4 minutes they've gone 1040 feet. So if they took the first row and the second row, they said, okay, 520 here, let me mark it, 520 here minus 260 here, that's what we're seeing there. And here they say 2 minus 1, that's what we're seeing here. And what do we get? We get a rate of change of 260 over 1 when we simplify the fraction, right? It's already simplified actually, but um, we will eventually see that we will need to do that. And if you did it for the other points, you get these same numbers, 260 over 1, okay? And you can try it yourself to do the math here, but essentially they're saying this minus this over this minus this is the same. This minus this over this minus this is the same, etc. The rate of change is constant, and it equals 260 feet for every 1 minute. It represents the distance the band marches per minute. Okay. Question here for you now is, what if we didn't use consecutive rows? What if we, let's say, took data points like from here to here and from here to here? Would you get the same rate of change? And explain. Give it a try. Now, graphically, rate of change is described as the slope of the line. Okay, so as they say here, the graphs of the ordered pairs, here's time as the independent variable and distance as the dependent variable. From the same problem we just did, the marching band, shown at the right, the relationship between time and distance is linear. They're walking at a steady pace. Okay, when data are linear, the rate of change is constant, meaning for every 1 minute, they go 260 feet. 1 minute, 260 feet. Constant, same number, right? Okay. Now notice that the rate of change found in problem 1 is just the ratio of the vertical rise, up 260, to the horizontal run, 1, between any 2 points. So the rate of change is called the slope of the line. Yep. And we're going to explore this a little bit right now. All right, here we go. What is the slope of each line? Well, this first line, you can see, what's the rise? Well, we rise 2 units. What do we run? We run 3 units. 2 over 3. The slope is 2/3 or 2 over 3. Here, what is the slope from this point to this point? Well, we're not rising, we're dropping. So we call it a negative rise. Okay, we rise -1, -2, -3, -4 over 1, 2, 3, 4, 5. -4 over 5. Okay, and the negative just has to be in the number somewhere, just once. And by the way, what do we need to find slope? We need the rise and the run. How much do you change vertically over how much do you change horizontally? So here's your got it problem. Give it a shot. One big important thing to note here is that as the rise is positive, the run is also positive, right? We're increasing by 2, we're increasing by 3. 2 over 3 gives you a positive number. It has a positive slope and it slants upward as you go to the right. Okay, here, one is going down, the rise is negative as the run is positive. So if one of them is negative as the other one is positive, we're going to have a negative slope, and it's going to slope downward as you move from left to right. Okay, and so what they're saying here is just uh, the notation of the slope formula itself. Okay, you can use any 2 points to find the slope. And by the way, we call one of the points point number 1, and so the x and y coordinates of it are x1, y1, the x coordinate of point 1 and the y coordinate of point 1. Okay, they call it point A, but either way. And x2, y2, or the second point, the x coordinate of the second point and the y coordinate of the second point. Okay, coordinates of point B. So to find the slope of AB, you use that slope formula. Essentially, you're saying how much did we change in the y direction? We changed 1, 2, 3 here. And what do we change in the x direction? 1, 2, 3, 4. So that has a slope of 3 over 4. Okay, and the slope is going to be some number whenever this bottom number isn't 0, because we can't divide by 0. Okay. The x-coordinate you use first in the denominator must belong to the same ordered pair as the y-coordinate you use first. So see where that comes from point number 2, then that one must be from point number 2 as well. Point number 1 must be point number 1. Okay, and one way that they write it is the slope, also known as m, you'll come to learn, is a letter that we use to represent the slope, is the change in y, that is the letter delta, Greek letter delta meaning change in y over the change in x. How much do you change in the y direction is the vertical direction, right? Over how much do you change in the x direction. Okay, so we'll get used to that more later. Right, so for this problem, they say what is the slope of the line through these points? Any 2 points you'll be able to tell how much you rise and run between them. And so what they're going to do is they're going to say, let's call this point number 1. And so we then say, if that's point number 1, we call that x1 and y1. Okay, and this is the second point. That's the x coordinate of point number 2 and the y coordinate of point number 2. Because what we're going to do is we're going to say, again, y2 minus y1. So what is y2? Let's take a look. Where do we see y2? Right here. Okay, so that goes there, minus y1, and y1 is there, so we've got negative 2 minus 0, okay, which is negative 2. And then what about x2 over x1? Where's x2? Well, this is x2 right here, that's a 3, minus x1, which is right here, minus a negative 1. And you know subtracting a negative is the same as adding a positive, so 3 minus negative 1 is the same as 3 plus 1, or 4. And we have to simplify this fraction, so when we do simplify it, we get a slope of negative 1/2. Okay? Oops. And they just ask here, does it matter which you use for point number 1 and which you use for point number 2? It does not. It'll work out correctly as long as you keep track of which points you used in which order. Okay, let's try this got it problem. Okay, so this is something I'm going to give you a little memory trick to learn. What is the slope of each line? Well, if it's a perfectly horizontal line, what you get is the change in y, 2 minus 2, since the y coordinate doesn't change, the amount that you rise doesn't change, the top number is 0. Okay, and 0 divided by anything is 0, so the slope is 0. And the way that I describe this is if we're talking about how many steps grandma has to take if she's going to be walking into a building, well, she would take no steps, 0 steps for grandma, right? Okay, versus a perfectly vertical line here, okay? And if the entry was up here on the second floor, then as you can see, the x coordinate doesn't change, and so we've got the bottom number is 0, and we're not allowed to divide by 0. They say that's undefined. So what about for grandma? Well, how many steps does grandma need to take? Well, she would have to scale the wall to climb up to the second floor to get in, and so we don't even define those as stairs. We say this is an undefined number of stairs because they're not actually stairs. Grandma would have to climb the wall to get up from there into there. Okay, so vertical lines, undefined. Horizontal lines, slope of 0. Think of it as the number of stairs that you would need to take to get from there to there. Okay, and you can try it with these. What is the slope of these lines? Okay, here's a quick summary of the slopes. If you have a positive slope, it's rising as you go to the right. If you have a negative slope, it's dropping as you go to the right. Horizontal slopes are 0 and vertical slopes are undefined. And I have this little character that I call Slope Man. Okay, Slope Man looks like this. That's a sad looking character, but this is his positive slope. This is his negative slope. This is his undefined slope. And this is 0 slope. And that is a sad looking slope man. Okay, sketch them out and maybe use them as a tool for reference. Okay, see how you did with these lesson check problems. I need to access the textbook and get these answers in. Uh, so I don't have the answers posted right now, but I'll get them for you shortly, and I will repost the video with the proper answers in here. Anyway, ask me any questions you got. Good luck.